الخطار وآله الأبهار وأصحابه الأخيار عدد نعم الله وإفضاله عدد نعم الله وإفضاله. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, the next opening remarks from the Dean of Engineering Faculty of Universitas Islam Malang. Please join me in welcoming Mr. Warsito, Master of Engineering. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asrofil mursalin sayyidina wa maulana Muhammadin wa ala alihi wa sahbihi ajma'in, amma ba'du. Dear Mr. Prof. Tosushi, Siyoshi, Imei, thank you very much. Come to Fakultas Teknik Unisma Malang. Yang kami hormati Bapak Rektor, yang kami hormati Ketua Panitia dan seluruh panitia kegiatan guest lecture Fakultas Teknik Unisma, yang kami hormati Ibu Novi yang selalu mendampingi untuk kelancaran kegiatan guest lecture pada pagi hari ini, dan tentunya perlu kesinambungan, perlu tindak lanjut kegiatan ini sehingga bisa bermanfaat untuk prodi baik teknik sipil, teknik mesin maupun teknik elektro. Bapak Ibu dosen yang bisa hadir pada pagi hari ini dan anak-anak sekalian, mahasiswa Fakultas Teknik, dalam situasi yang baru saja ujian, kalian sudah bisa hadir di kampus untuk acara yang sangat berharga, yang sangat penting untuk pengembangan ilmu pengetahuan. Salawat dan salam semoga senantiasa terlimpahkan pada junjungan kita Nabi Agung Nabi Muhammad SAW. Bapak Ibu yang kami hormati, pada kesempatan lain ini, sebagaimana kegiatan yang akan dilaksanakan pada siang hari adalah guest lecture dari Prof. Toyoshi Imei, sudah jauh-jauh dari Jepang, Yamaguchi University Jepang. Beliau hadir, alhamdulillah, untuk menambah wawasan kepada kita semuanya. Yang mengangkat pada hari ini adalah Waste Management in Japan. Sedikit yang saya ketahui tadi dari informasi Bu Novi, bagaimana Jepang mengelola air. Saya hanya bisa membayangkan apa yang disampaikan Bu Novi tadi itu, bahwa Jepang itu hampir tidak ada air yang keruh, tidak ada limbah. Semua limbah yang ada itu semuanya melalui proses yang diolah begitu dia keluar ke area yang general, yang umum, air ini sudah kondisi yang sangat jernih. Dan itu adalah impian kita semuanya. Bagaimana kondisi kita, alangkah indahnya kalau kita ini melihat di sekeliling kita air, sungai, saluran, apapun yang ada di situ kondisinya jernih. Dan ini tentunya impian kita semuanya. Impian kita semuanya. Air adalah merupakan sumber daya alam yang paling penting di planet bumi ini, sebab menjadi, selamat datang Pak Rektor, menjadi esensi dari semua kehidupan manusia. Binatang, tumbuh-tumbuhan, manusia, lingkungan, semuanya air adalah esensi yang sangat penting bagi kehidupan manusia. Oleh karena itulah maka tentunya air ini adalah yang harus kita lestarikan juga untuk generasi-generasi kita, generasi-generasi kita yang akan datang. Begitu pentingnya air untuk kehidupan manusia. Tentunya teknik harus ikut andil di dalam mengelola air, khususnya di negara kita ini. Bagaimana Jepang mengelola airnya, insya Allah nanti akan disampaikan oleh Profesor Toyoshi Imei yang akan menyampaikan tentang bagaimana mengelola air sehingga Jepang dengan kondisi lingkungan yang sangat bersih, air yang sangat bersih terwujud di mana-mana. Dan itu adalah impian kita semuanya. Dan semoga acara pada pagi hari ini, lecture ini, tentunya khususnya adalah tentang air untuk kehidupan manusia. Kita belajar bagaimana mengelola air di Jepang, dan tentunya itu adalah bagian ilmu bagi kita untuk bisa menerapkan ilmu yang ada di Jepang untuk bisa diaplikasikan kehidupan kita di Indonesia ini. Semoga kegiatan ini bermanfaat bagi kita semuanya, bagi tanah air kita Indonesia, bagi kehidupan manusia yang akan datang. Oleh karena itulah nanti mohon dengan hormat kepada Bapak Profesor Dr. Haji Maskur NSI yang berkenan untuk memberikan sambutan sekaligus membuka acara Gus Rektor pada pagi hari ini. Tentunya kami juga mewakili seluruh panitia sudah berusaha maksimal untuk kegiatan ini. Tentunya apabila ada kekurangan di sana sini, tentunya kami mohon maaf yang besar-besarnya. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the speech. Ladies and gentlemen, the next agenda is the opening remarks from the Rector of Universitas Islam Malang. Please join me in welcoming Professor Maskuri, Master of Science. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. Hamdan wa syukran lillah. Allahumma sholli wa sallim ala sayyidina Muhammad wa ala alihi wa ashabi ajma'in, amma ba'du. Respectable keynote speaker of this International Guest Lecture 2023, Professor Toyoshi Imei, from the Division of Environmental Science and Engineering, Graduate School of Yamaguchi University of Japan. Respectable Dean of Faculty of Engineering Associate, Professor Insinyur Warsito STMT. Respectable Vice Dean, Head of Study Program, Faculty Member, Student, ladies and gentlemen, on behalf of Universitas Islam Malang, I am very happy to welcome our keynote speaker and participant of this International Guest Lecture 2023. Unisma Malang is under Nahdlatul Ulama Board. Nahdlatul Ulama is the largest Muslim organization in Indonesia. Unisma Malang ranked number 1 out of more than 260 universities under the Nahdlatul Ulama Board. Unisma Malang is also under the Ministry of Education and Culture and the Ministry of Religious Affairs of the Republic of Indonesia. In the Malang region, Unisma ranked number as a private university. Ladies and gentlemen, the University of Islam Malang is very active in developing international collaboration and reputation. Our student body is about 17,000 students. Our student alumni and partner are coming from 38 provinces across Indonesia and from 39 countries. Recently, Unisma Malang has been accredited as an excellent university by the National Accreditation Board of the Republic of Indonesia. We received full accreditation from the International Accreditation Body ASI in Germany. Also, we had been assessed by FIBA Germany for our 7 study program. This internationalization are our effort to achieve our motto, University of Islam Malang is from Nahdlatul Ulama for Indonesia and for the world civilization. Ladies and gentlemen, environmental engineering is a professional engineering discipline related to environment science. It is related to science topics to create solutions that will protect and also improve the health of living organism. It also improves the quality of the environment and human life. Environmental engineering integrated scientific and engineering principle to improve and maintain the environment to protect human health, protect ecosystem, and improve environmental related adjustment of the quality of human life. Environmental engineers provide solution for wastewater management, water and air pollution control, recycling, water disposal, and public health. Ladies and gentlemen, I have visited Japan many times. Japan is one of the most developed countries in the world. The expertise of Professor Tsuyoshi Imai from the Division of Environmental Science and Engineering Graduate School of Yamaguchi University of Japan is very important for all of us. Because environmental engineering is becoming one of the crucial issues in today's era to achieve sustainable development goal. Therefore, this international guest lecture is important not only for our campus internationalization but also for sharing best practices and state of the art in the area of environmental engineering. Ladies and gentlemen, on behalf of Unisma Malang, I would like to deliver my appreciation to the organizing committee who has prepared, organized, and conducted this International Guest Lecture 2023 successfully. Our appreciation also goes to our keynote speaker from Yamaguchi University, Japan. We believe that this international guest lecture can strengthen our comprehensive understanding of environmental engineering to achieve our sustainable development goals. Ladies and gentlemen, I hope we can benefit from this important international guest lecture for our personal and professional development purposes by saying Bismillahirrahmanirrahim. I officially open this international guest lecture conducted by Faculty of Engineering University of Islam Malang 2023. Thank you very much. Wallahul muwaffiq ila thoriq. Assalamualaikum warahmatullahi wabarakatuh. And have a great day. Thank you.
Thank you for your speech. Ladies and gentlemen, the next agenda is giving souvenirs and documentation. Yes. Tugas. Professor, Rector, and Dean, please go in front of the table. Okay, thank you. You can come back to the chair. The next is Dua, led by Mr. Taqiyuddin Alawi, Master of Engineering. Time is yours. Changed by Mr. Nurobi. Time is yours.
Ala hadiniyah al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillah rabbil alamin hamdan yuafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhika wa 'azimi sultanik. Allahumma salli ala nuril anwar sirril asrar wa tiryakil awiyar miftahi babil yasar سيدنا ومولانا محمد المختار علي لطار سبيل الخيار عدد نعم الله وإفضاله اللهم حسن مقاصدنا في هذه الدنيا والآخرة وحسن مقاصدنا في تعلمنا وحسن مقاصدنا في حوائج جامعتنا أونسما اللهم يسر ولا تعسر فتيسر العسير حاجاتنا إليك كثير ربنا هب لنا من أزواجنا وذرياتنا قرة أعين واجعلنا للمتقين إماما ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار صلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Ladies and gentlemen, as we have finished the opening ceremony for this meeting, it is time to continue to the main agenda. We have here the guest lecture speaker, Professor Suyoshi Imai, and the moderator, Ahmad Farooq Al-Hikami, Master of Science, who will guide this session till the end of the meeting. So, without further delay, allow me to give the floor to the moderator to handle the agenda. At your convenience, Mr. Farooq.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. So, we begin the guest lecture today with our honored guest from Yamaguchi University, Professor Suyoshi Imai. So, please let me introduce a short introduction of his profile. So, he is from Graduate School of Science and Engineering, Division of Environmental Science and Engineering, Yamaguchi University in Japan. He published a lot of papers, so quite impressive works, 150 Scopus Index paper, and he has expertise on biological wastewater treatment and also biological treatment of organic solid waste and water environment conservation. So he's coming today to give a speech about wastewater treatment, and I hope that all of the students and faculty members of Faculty of Engineering can obtain much information for this today's speak. So we will have a questions in English, but if you worry about speaking English, you can speak Bahasa and I can translate for you. So don't be shy, for sure. Okay, without further ado, please welcome Professor Suyoshi Imai. Times and place is yours. Give a big round of applause.
Yeah. Hello. Thank you very much for the very the kind introduction for me. The title of the guest lecture today is the wastewater treatment and management in Japan. So. Please next. Please next, please. Next, please. It is the figure or the map of the Japan. The left-hand side is the small part is the old Japan, and the center of Japan we have the Osaka or Kyoto and Kobe city. We call this area is a Kinki area, and this area is so many people 1,500 15 million people that live in here. So the very important the water resource is Biwa Lake. As you can see, the center of the blue part is this is the Lake Biwa. That one is the supply to the waste, the supply to the water to Kyoto, Osaka, and Kobe area. So that's water quality, how to control. or how to keep the clean is the very important. So we have to we have to think about the how to the manage of the wastewater treatment. So please, next. And skip please. Next please. And the water quality of the lake beaver is in before the upper part of the figure is the solid line is the transparency. Transparency is how can I say we can how the depths we can see. So but in 100 years ago, very before, but at that time is we can see the inner depth is 10-meter depth we can see inside of the lake. So but that is very clear. But in these 30 years or 40 years, it's getting dark, getting bad. And in the yellow graph of the blue the circle is the it's maybe please imagine this is the COD, a kind of the COD. The COD is the chemical oxygen demand. Chemical oxygen demand is the if you have the 1 liter of the river water, how for clean up of this water, how many amount of the oxygen is needed. That is the COD. This is the way of the chemical the way. So the some we use the some chemical to clean up this 1 liters of the water is how much of the oxygen is needed. So that is the if the COD is more, is the water is more dirty like this. So very low amount of the COD is a very clean water we can say. But the as you can see the gradually increasing and not a little decrease. So it's we can see it's a little improve, but not enough. Why the water quality is not recover? I will talk to you in the next or another slide. But at that time at this area is many kind of the countermeasure. We instruct of the construct sorry and we construct of the many the wastewater treatment facility, but it still have the not so good the recovery. It's because of the COD's contents. That means the COD and the before the COD contents the explanation. I have to talk about the BOD. BOD is the biochemical oxygen demand. Biochemical oxygen demand is the same as a COD. The 1 liter of the lake water or the river water, how much of the oxygen is needed to clean up this water. But this measured by microorganisms. Microorganisms, how much the decrease, how much the oxygen is needed. But the chemical oxygen demand is measured by the chemical. So the difference is what we use. Microorganisms use or chemical use. Chemical is the some cases very strong enough compared with the microorganisms. For example, I'm very sorry. This kind of the sweets is very easy to degrade, degrade for us. But how about the wood? We cannot degrade. We can eat, but it's very difficult to degrade. This is the same things. BOD is this kind of the easy to degrade, but COD include of this kind of the very difficult to degrade. So the COD is a little difficult to decrease, but include of the very difficult to degrade by microorganisms. So in here is there are no data, no information about the BOD, but the BOD itself is goes down, but COD is still. So what mean? We have to the more the higher wastewater treatment. We call advanced wastewater treatment. So I will introduce some of them today. But anyway, this is the background. So please next. And please skip the next. Of course we have to I already talked to you the wastewater treatment is the many place is already introduced in around the lake, but the normal wastewater treatment is not enough, because the normal wastewater treatment is I already talked to you. BOD can decrease, and some solid, suspended solid we call in this area is we call SS. SS is suspended solid. That kind of the one is possible to decrease by normal wastewater treatment. But nitrogen and phosphorus is very difficult to remove all. Of course, a part of them is possible to delete, because if we eat the food, is of course as you know, only the rice we eat every day, every time, not no eat of the another, only rice. It's maybe your health is not so good. Of course, we have to eat the protein or some mineral or the vitamins or the something. So we have to eat the vegetable or some. So that means the microorganisms need BOD, but the nitrogen and phosphorus they need, but not so much. But in the wastewater, we waste or discharge the wastewater. That is the include of course the BOD, COD, and nitrogen and phosphorus. But the nitrogen and phosphorus is a little higher. I mean, I'm very sorry, not so clean, not so clean. But we goes to the toilet is we discharge. So that's include of the ammonia and phosphorus. That is maybe the balance is not so good for the microorganisms. Microorganisms is for example, BOD is 100, and nitrogen is only 10, and phosphorus is only 1, 110 to 1. That's kind of the balance they want. But we discharge the wastewater BOD, for example, the 100, but the nitrogen is 50, and phosphorus is 10, too much. So the nitrogen and phosphorus is cannot removed by microorganisms, and that's remaining is discharged to the water environment. And nitrogen and phosphorus release to the water environment. What happened? Eutrophication. Eutrophication is the algae or the phytoplankton. Phytoplankton is it's not zooplankton. It's the phytoplankton, like a plant in the water. That one is the growth by the nitrogen and phosphorus, water and sunlight. So no need BOD or COD. So the eutrophication. So the upper part of this slide is the N and P are the loading control. So that means the nitrogen and phosphorus we also reduce or delete from the wastewater. That means. So please the next. And the next please. And that one is the wastewater treatment in Japan. The dark green, this is the most, the bigger part, is the wastewater treatment plant. I mean, that is we call sewage. That is the piping system. That we introduce the inner city area is the piping system. And our house is connected to this piping system. And then we discharge the wastewater. All of the wastewater is collected and goes to the wastewater treatment plant. And all the wastewater is treated and then released to the water environment. And another is the jokaso is we call jokaso, but this is Japanese. So it's we call it a septic tank. But maybe you are thinking about the septic tank is only the night soil. Night soil is the toilet water. The toilet wastewater is your house. Maybe I believe your house has some septic tank for toilet. But how about the other wastewater? Other wastewater is, for example, the shower and washing machine. This is a hand, but the washing machine and the kitchen is all the place of our house is discharge the other water. This water is how you treat. You don't treat. Yeah. So it's goes to back to the soil. It's some case is okay, but the many case is goes to the underground water. Yeah, some the contamination is. So that's kind of the things that we have to control. So all the wastewater have to treat. This the thinking way is we develop the combined septic tank. Combined is all the wastewater is accepted. So the tank is more bigger. Maybe 2 or 3 cubic meter for one family. In Japan is one family is not so much. I'm very sorry. So maybe 4 or 5 person. Yeah, 5 or 6 or some like this. It's this the number of the people use the 2 or 3 cubic meter size. So that size is okay to accept. In Japan, I'm not so sure in Indonesia in exactly, but the one person one day, Japanese, I use the water. One day, I use the 200 or 250 liter per day. So if my family is 4, it's 1 cubic meter per day wastewater discharge. So one day the 2 cubic meter it means the wastewater treatment it takes 2 days. 3 cubic meter is 3 days. This is very enough time for treatment. So I will introduce later, but our normal wastewater treatment called the activated sludge process. Activated sludge process is maybe 16 hours or some for the wastewater treatment time. So compared with that kind of the process, our process have more time. It's smaller system is more time is need. Bigger system is some operator is. So a little higher or the more higher, the more technical, the wastewater treatment is possible. But we introduce the septic tank. The septic tank introduced in the soil. So if we don't have the yard, it's a little difficult to introduce. But anyway, that's kind of the facility introduced. It's it takes and then no one take care of them. Of course, it is better to 1 year one time or at least 2 year one time. The maintenance is it mean a clean up or some maintenance is need. But some case is not so frequent because of the money. The maintenance it takes some money. But as you know or not, I'm not so sure. But in your septic tank, it is need to remove the sludge. Maybe one time 1 year or the 2 year one time or some. So that is a kind of the maintenance. So that kind of the maintenance is need for septic tank. So anyway, we introduce not only the toilet water, but also all the wastewater have to accept and treat and release or return to the water environment. So this is the thinking way for Japanese the management of the wastewater. So please change. And the next, please. And this is the thinking way. Our thinking way is we divided the urban area and rural area. The urban area is like this Malang, center of the Malang city. Is so many people live in. So this is the urban area. And we introduce this kind of the high population area is piping system. So the piping system is under the load. Basically, we construct of the piping system in under the load, because the load is I think in Indonesia is the load itself is belong to where? Public? Yeah, government. So I believe so. This is the government the space, so it is easy to introduce. If we introduce the under the another house, maybe it is need to the permission. Very difficult or very complicated. So it is need to the under the load. But I suppose to from now in your city, Malang city, is introduce of the piping system, sewage we call. Sewage is introduced. Is it possible?
It's quite difficult because the land structure is
Yeah.
is hills. And
Yeah.
Sometimes it's,
Yeah.
I don't know if civil engineering people have an idea.
Yeah.
Because we also have expert on that wastewater treatment.
Yeah.
So maybe next we can discuss.
Yeah. So at this, if the introduce of the piping system, it's more easy to control of the collection, and of course we make or the construct of the wastewater treatment facility finally, but the collect and treatment and then release. So the condition is getting better. I think dramatically getting better. I think, but nowadays is some case is I can see the some water surface in some river in here or the other city. I don't want to use the tap water for the tap water. Some case. So water quality the recover or the
Some area
Yeah.
cannot use the water resource from the mountain.
Yeah.
So it's directly from the
Yes.
water resources. But some area the wastewater treatment,
Mm.
they like any company on the route.
I see. So not only we rely on the mountains water, areas water, we have to control or keep the clean. The condition is the middle or the lower stream, downstream. So I'm very sorry. The urban area is our thinking way is the high population area is introduced to the piping system, and the rural area is they are divided to the. This is the maybe in Japanese style, but the one area is the farming village, the sewage treatment system. It's our Ministry of the Agriculture is thinking some rice field village is have to introduce is that kind of the convenient. Because of course we have to pay something for the discharge this wastewater, but if we connect only discharge, no need to the maintenance. Of course, some money is need payment, but that is the very convenient. But how about the septic tank? It is need to the some maintenance every year. So someone wants to wants to connect the piping system. So the farming village is the wastewater treatment system developed by Ministry of the Agriculture. And I didn't say the urban area is construct of the sewage piping system is constructed by Ministry of Construction. So it's divided two types. And the last one is the less populated area. This area is not farming village, but the low density, population area. Of course, this kind of the people is. And please think about here is the urban area, and the population area is only one house is, and the 10 kilometer far. We have to connect of the piping system. Thinking about the cost, it is not. So that kind of the rural area is introduced to the that place is the Jokaso, but this is a combined septic tank. Septic tank, but all of the wastewater accepted. So these three kind of the thinking way in Japan. But the farming village, the farming village, small wastewater treatment system is a little special in Japanese style. So maybe we can think the normally is the urban area or less population area. And the less population area is of course some cases collect and treatment together is okay. But some very less populated area is introduced the septic tank, the combined septic tank system. This is our management system in Japan. Please next. And how we divide or the big wastewater treatment plant is where the center of the blue marked one the water color of the low water color is this is a lake, and the red mark 1, 2, 3, 4 red mark. 4 red mark is a very big wastewater treatment plant. That means that area is the high population area. And other area is introduce the combined septic tank like this. So please next. And this is the wastewater treatment plant. And this is, as you see, this is island. And this is the place to the southwest place. Southwest place is the Lake Biwa. Is the I already show you the Lake Biwa is like this shape. So this is the we call the North Lake, and the south one is we already of course recall to the South Lake, and this wastewater treatment plant is at the southwest place, and the south part is discharge to the river, and go through the Kyoto and goes to the Osaka and release to and discharge to the sea. So the north area is the upstream, and south area is downstream, and north area is very wide and very deep, and the south area is unfortunately small and shallow. So the water quality is the upper stream and downstream and very small and shallow. Is the not so good. It's naturally, and around there is a very high population area. So we have to make this kind of the wastewater treatment facility. And this is the island. Why the island? This is the actually it's made by human, artificial island. Why we have to make the island and construct of the wastewater treatment plant? That's why the around the for example the you can see the island, and the upper part is some land. That is the main land, and that mainland people don't or couldn't accept to make this kind of the wastewater treatment plant in their neighbor. So maybe it's please think about by yourself. Is if your house is here and wastewater treatment construct here, is can you accept? Yeah, maybe you cannot. Of course, wastewater treatment plant is necessary. It's very it's need, very high necessity. But the construct in your neighbor is maybe many people don't want to. This is the thinking is okay, but emotional no okay, like this. So so that's because of the island is making, and then the north the upper part, half upper part is as you can see, it's a playground. It's like a playground. So it is open for the around the people to use freely. So please please allow the to make this kind of the wastewater facility around near your house like this. So this kind of the how can I say, this kind of the yeah yeah, strategy, or we can say it's a strategy or not, excuse or something. I'm not so sure, but anyway, this is the layout. And then the half of the part is the wastewater treatment facility. So please, next please. And that one is the planning and the actual present is the 2014. I'm very sorry, it's the little the old information. But in these 10 years, the sewage itself is no more construction, because some of you already know in Japan is the population is decrease, start to the decrease. That means especially in a rural area. So in Japan is the getting the decrease to our population. So especially in the rural area is the population is decreased. Only increase the population is at a big city. Tokyo, of course, and Osaka, of course, Kobe, of course, and Fukuoka. Do you know the Fukuoka? It's at the South Island. Yeah, South Island of Japan. But the Fukuoka is a center of the Kyushu. We call this South Island is the Kyushu Island. That Kyushu Island center city, center prefecture province is the Fukuoka. The Fukuoka is my hometown. But anyway, only the Fukuoka is increased, but other province in Kyushu area is decreased. That kind of the situation is I can say it's already finished to construct. From now, it's change to the maintenance period. Maintenance is at a very longer time. It takes 50 years. And our planning of the wastewater treatment is lifetime is 50 years. So after 50 years, we have to think about newly the wastewater treatment make, construct, or some renewal, or not renewal, it's a renovation. Is need or not, like this. And of course, partly the piping system is break down. So how to maintain is nowadays is in Japan is a very big problem, because before 50 years big city is already construct of the piping sewage system. So big city is now faced to the maintenance period. So they have to use the make big money. So how can I say? 50 years ago is the sewage treatment is suddenly very increase especially in Japan. So after 50 years need to the maintenance is very suddenly decrease. That means that we have to prepare the big money for maintenance. So if you introduce to this kind of the facility, the piping system is also, and wastewater treatment system also, or as you can see, it's the road itself, or how about the bridge, how about the tunnel? In Japan is so many tunnel, as you can see. In the Shinkansen is the 1/3 is the tunnel system. Yeah, yeah, yeah. So in our highway is some case is so many tunnels. So everywhere we make the tunnel. So anyway, this kind of the tunnel is if we construct, but after 50 years, we have to continue to maintain. No maintenance is some case is breakdown, very big accident. So it's the same thing about the wastewater treatment facility, the piping system or the wastewater treatment plant, or the tap water is also. The gas system is also. In some cases, the gas is use the gas cylinder, as in Japan is also. But in some cases, the piping system in the ground. So how to control or maintenance is very important. Important for near future. In Japan is at this moment we have to control of the thinking about the maintenance all the facility. So please next. And then this one is the influent is low wastewater. Low wastewater. So before the wastewater treatment, the plan is the planning, and the 2014. This is the actual value. So SS is a little lower compared with the plan, but the BOD is 180, 180, 180, and 180. It's very exact the planning and the actual. It's I think it's very well the planning. And the COD I have to say to you in Japan is the COD used by the manganese method. In a world standard is the chromium method by the COD measurement. Yeah, measurement way is different. Very roughly speaking, the COD the chromium is 100. Is the COD manganese is maybe 50 or 40. Very low ability of the oxidation. Because this kind of the lower oxidation, higher oxidation is the more exact data we can get. Lower oxidation ability is not so exact the information from the water, but we select the COD manganese because of the chemical. The chromium method is use the chromium. The chromium itself is the very toxic material. Plus, another chemical is the include of the mercury. So the chromium and mercury include of that chemical. So we cannot use the COD chromium method because we already have the very heavy experience of the Minamata disease. Do you know the Minamata disease? It's mercury contaminants. Is the disease. Very many people is the very suffering, and some of them is already died. So that kind of our history is use the mercury for water quality measurement. It's a little difficult. They said in the Ministry of the environment thinking like this. So we select the COD manganese. So anyway, the Tn is a nitrogen, total nitrogen, and Tp is total phosphorus. And please see the effluent. Effluent is the after treatment. After treatment is the standard. Standard is decided by the upper part, decided by the national. It's the environment, the Ministry of Environment. That means the central government decide of that upper value standard. But in Lake Biwa area is they think more severe control is needed. So they set the more severe standard for themselves. And that's the wastewater treatment plant. I already show you that island. The wastewater treatment plant is the planning is that kind of the very clear the water level, and 2014 is the actual value. Actual value is the SS is ND this is not detected. No SS. SS is a very small size of the solid in the water. Not here, of course. And the BOD is 0.8 and COD is still half. But the and nitrogen and phosphorus is at a decrease. The time? Yeah, it's okay. Yeah. So please next. And the half of the in planning is that all the place the government wants to make the wastewater treatment plant, but the yellow part is that already construct, and then the as I already talked to you, the population is start to the decrease, so no need to the expand to the extent to the wastewater treatment facility. So the yellow part itself is maybe almost finished. Please next. And please next. And this one is the total wastewater treatment plant, the treatment facilities. And here is our house, and the correct wastewater goes to the pumping system. The pumping system is mean maybe as you can imagine easy. This is a land, but the wastewater piping is it is need to that kind of the angle because of the flow. So for example, very flat area is 1 kilometer, and how many how deep the ground. So it is needed like this. So pumping system is here. And from here is a wastewater treatment facility. So that one is the primary first sedimentation tank. And this one is the aeration tank, or that one is it's have a color. It's the microorganisms color. This is we call activated sludge. But the sludge is a little misunderstanding. So it's microorganisms, activated microorganisms. It's this color is like brown. So we call it a sludge. And then they can eat of the BOD or small SS, but they need oxygen. So it is need to the aeration. Aeration is mean the air using air pump and put in the many air in the tank. So here is the aeration. And then after we call this is the biological treatment. And then after wastewater treatment, we have to divide of the treated water, clean water, and microorganisms. So here is the separate of the microorganisms and the first sedimentation tank is the only separate of the a little bigger SS from the wastewater, and it takes 2 or 3 hours. The primary sedimentation tank, and the aeration tank is the biological wastewater treatment. Is it takes 8 hours, and then the separation of the microorganisms and treated water, it takes 4 or 6 hours. So very roughly speaking, 2, 4, 8. So 14 hours for wastewater treatment. Yeah. Okay. So that kind of the wastewater treatment is very not so difficult. I want to say the only 3 steps is the one is the sedimentation and biological treatment, aeration, and finally is the sedimentation. So only 3 steps. So I can say the wastewater treatment process itself is not so complicated, But of course, it takes money because mainly it's the aeration. Aeration is very many electricity is need. So of course, it is many thinking way for wastewater treatment process. So it's okay, but anyway, please remember the collection of the wastewater and wastewater treatment itself is not so difficult. And the Japanese way is high population area and low population area is divided, and how to collect or how to treat is divided. That's kind of the management of the Japan way is if it's better for thinking it's your country, it's very happy for me. Thank you very much.
Give a big applause to Fakultas.
Okay, thank you for the speech, Professor. It's really impressive. And I think we are moved to the question and answer session. So I'm going to open for three people to ask, maybe, and two from the faculty members and 3 for the students. I think it's sufficient, right? Okay. If you have any question, please raise your hand. Okay. Dr. Imam, he is the internal office chair. Okay,
Thank
Pak
you so
Imam.
much,
Yes.
Prof. My name is Imam Mahyudi Karimullah from the Office of International Affairs of Unisma Malang. My background is education, but I don't have any background in water and waste management. But the introduction from your presentation make me shocked, because even though I'm not coming from the background of water management and environmental engineering, but I believe and I think your topic is very, very important for family. And thank you so much for bringing this, even though I'm not from environmental engineering, I'm from the education background. But you mentioned that if the waste in our family is not properly managed, it's going to be a big problem. Waste from washing machine, and then waste from our restroom or toilet, for example, or waste from our kitchen set. And you also give a picture how a government or a city should have the water and waste management system in the level of government system. Malang is a city of education. There are so many universities, and then many students, many professors. I do not know because this is the first time for me listening to your talk. I mean, listening to this topic. After visiting Indonesia many times, in your opinion, how about the water and waste management system, maybe in Malang or maybe in Indonesia as a whole? Did you find the, what we call it, government best practice in Malang or in Indonesia that has tried to integrate the wastewater management to control the waste from the houses, the family? I know in Surabaya they try to, what we call it, to purify the river, and then they try to make it consumption water. But that's specific case. What I mean is there any waste or water management that can try to solve the waste management from houses, like integrated wastewater management that can solve the problem of waste from many houses? Because Indonesia, Java, especially Malang or city, it's a very populated, very dense population. And if this is not handled carefully, then it's going to be massive dangers for the public health in the world. And how researchers, scientists disseminate the importance of this to the families, the families especially that are not aware yet, because usually they are relying on the water, the groundwater. When you presented that the waste from our household can be going down into our groundwater, which is going to be problematic, and then so what is the latest innovation that can solve that problem? A week ago, my friend from Sustainable Business Innovation in Netherlands brought a product. I think it's made in Europe, and the product can purify contaminated water. So how is the progress on that area?
Okay.
Can it be also an alternative solution? Because that product is from bacteria, something like, but can purify the uncontaminated water naturally without affecting environment. Thank you so much, Prof.
Okay, thank you, Pak Imam, for the question. So maybe we wait for one question more, okay? Okay. Any question? One more, I think, because Pak Imam has question a lot of from the product innovation and opinion. Student, please raise your hand. Yusril, do you have question? Please, one student. I want to hear your voice. No? Don't be shy. I can translate for you. Okay. Okay. Faculty members, please, if you have any question. Okay, Pak Artono, welcome.
I'm Artono from. In our city, we have a very different situation. We have abundant fresh water, especially in our city. So, but we have a very low self-awareness about this thing. So, basically, we don't treat our wastewater at all. So, what I want to know is how can we educate our people to achieve awareness like in your country. Thank you.
Okay, thank you. One question, Pak Artono. Okay, ya. Okay, no more questions. Okay, Dr. Eko, please. Yeah.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Each house here has a safety tank.
Yeah. Individual safety tank. Yeah.
Yes.
Yeah.
Unlike Japan.
Yeah.
May I ask you about the water inflow the reservoir?
Okay.
Ambung is a reservoir, a little reservoir. This water contain water from was the water from clothes
Farming. Sawah.
washing clothes.
Oh, washing
from,
machine. Washing machine. Okay.
Yes, from a river
Okay.
or a channel.
Okay.
It is the water is contain washing clothes. Yeah.
Okay, so detergent, phosphoric. And
Yeah,
everything.
detergent. Yes. May you can advise for me to improve the water because I like to research about the water in reservoir. Yes.
Yeah, thank you. One.
Thank
Okay.
you.
So I just summarize a little bit, Professor Imi. So one question, the first question from Pak Imam, Dr. Imam, is about the your opinion and latest innovation about the wastewater treatment in your knowledge. And Pak Artono is how to educate people, especially Indonesian people, to aware about the wastewater management. And Dr. Eko, she is also researchers in wastewater treatment. So I think it is maybe very useful if how to remove detergent in the wastewater and to improve the quality of the water. Okay, time and please yours. Thank you.
Thank you very much for your questions. And the first one is maybe today is I cannot show you the structure of this combined septic tank, but the combined septic tank itself is already constructed in Japanese style. So maybe that one is how can I say modify to the Indonesian style or the Southeast Asian style for fitting. So the more and the important point is the more lower cost. Is nowadays is in Japan is maybe at least 1 million Japanese yen. So to the Indonesian rupiah to multiple 100. Yeah. So
1 million. Yeah. Yeah. 1 million Japanese yen, multiple 1,000.
Yeah.
Okay.
So if this kind of the adaptation, I want to say adapt of the each countries. That kind of thinking way is very simple. All the wastewater is collect and treat. And of course, if your land have the space, is more longer time, more bigger tank is making is the more easier the structure is okay. So and the in nowadays is the some solar cell is the already the we can buy. So that kind of the solar cell is can move to the aeration. Yeah, not so big aeration pump is okay for the one families. So that kind of the way is the possible to make the new the septic tank for Indonesian style.
And one question I think for the water purification. So Pak Imam mentioned about the current style in Indonesia that we use kind of like a filter for water. So before we drink, we filter the water and then we assume that the bacteria and everything dangerous materials can remove. So what's your opinion about that?
The water purification is it depends on the size of the pore. So the use the filter, but that filter is not same. Nano filter or micro filter is the maybe 1,000 times the big pore and small pore, and of course the very small pore. For example the change to the seawater to drinking water is that kind of the one is very expensive and it takes energy, but all of the material is can reject. But the normal maybe water is the of course the almost of kind of the bacteria and some case of the virus is can reject, but some toxin is the toxin itself is the size of the size of them is very small compared with the microorganisms. So that kind of the toxin is through some case. So I believe this one is not the big amount of the toxin, but if you want to think about the more safety is more smaller size of the filter is need.
And then next question, Professor, about the how to educate people to aware about the wastewater.
Yeah, that is the very important, I think. But how can I say, from the small is for example in Japan is that kind of the word is 3 years learning is all the life they can remember. So maybe the very small children
Kids,
is teach them, for example, the waste is threw away is prohibited, or the water is very important. So the wastewater discharge directly is not
prohibited.
Like this. The very longer time is need, but for example the kindergarten or some is the start to educate of this kind of the things, and especially in the primary school. First or second year is maybe teaching them. It takes a time, but very it's a very important things, I think.
Thank you. And the last question about how technology to remove detergent from the wastewater.
The detergent itself is the nowadays is in Japan is not so big problem, but the some kind of the detergent that we call LAS, the LAS, is it's the main contents of detergent or for water clothing, clothes washing. But that one is in wastewater treatment plant is easy to degrade. Some company to make the detergent they said, but actual check is that detergent is partly degrade,
Okay.
not completely.
Mm.
So that's partly degrade is we call it a byproduct.
Okay.
That byproduct is goes to the environment. What kind of the effect is that we cannot know
Okay.
at this moment. So if you can, it's some case is a little difficult, but I recommend to the soap.
Soap.
Yeah.
Okay.
To partly is replace to the not only the detergent, partly use the soap.
Okay.
It's the soap itself is the biodegradable.
Ah, I see.
So
yeah.
some case is a little expensive. Soap is a little
Soap
expensive compared
shower.
with the
For
detergent.
shower.
The shower is
okay.
the
Okay, washing, face,
It's
okay.
it's more better.
Ah, I see.
The soap.
Okay.
I think.
Yeah.
But I don't recommend the hair.
Ah, I
It's
see.
the hair
Shampoo.
washing of the soap is not so good. Yeah, like this. So
Okay.
anyway, that's kind of the thing.
Okay. Thank you. Give a big round of applause to Professor Ime. So maybe some of you would like to ask question. You can send email to him, right, Professor? Okay. And maybe I will share the email to you. And maybe one last statement, Professor. Maybe our students would like to get a higher degree in Yamaguchi. Is there any scholarship available, or how to prepare at least the first preparations for the students, so Yamaguchi can accept them for the postgraduate? Yeah. Do you have maybe some suggestions for them? Because I think some of them would like to fly to Japan for study. I think hopefully next year. Yeah.
The very the at first is our Ministry of Education supply to the scholarship for the master student and the doctor student.
PhD students. Okay.
So PhD students. So if you get that scholarship, it's very lucky.
Okay.
It's full recover.
Okay, full recover.
So maybe the master is 2 year, but plus half year for
Okay.
preparation for the
Japanese language.
language education.
Okay.
And the PhD student is also half year for
Okay.
education of the scholarship. So 3.5 or the 2.5 years scholarship.
Okay.
But that one is separated to the two types. One is the Japanese embassy.
Okay,
in
Japanese embassy.
Yeah, Japanese embassy recommendation. So,
G to G,
yeah.
government to government. Yeah.
Yeah.
Okay.
So this case is I'm not so sure.
Okay.
Because in here you
Have to
get
come
the
to embassy.
information
Okay.
and apply to the
Yes.
Japanese embassies.
Embassy.
Japanese embassies are the recommendation.
Okay.
That process is I'm very sorry,
Yeah,
not so
okay.
in detail. I don't know.
Okay.
And the other is the universities the
University,
recommendation.
okay.
So if you want to come to my university, is I can recommend to the one student, but this is very competitive.
Okay, yeah,
because the one university is not only the faculty of engineer.
Exactly.
All the university is recommend only 2 or 3 students
exactly.
per year. So
Okay.
I recommend, but select or not is it
Depend
depends
on
yeah.
the scholarship. Okay, thank you. Big applause to Professor Yume once again. Okay, thank you, Professor. So we end our discussion today. So if you have some question or want to have collaboration, please send email to him, and I will pass by message to you. Okay. Thank you once again. I will end this session. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
In conclusion, today's guest lecture on wastewater management in Japan has provided us with valuable insights into innovative approaches and sustainable practices. Let us carry forward this knowledge to inspire positive change in our own communities. Thank you to our distinguished speaker for sharing expertise and fostering a deeper understanding of environmental stewardship. Ladies and gentlemen, see you in the future agenda. Big thanks to Mrs. Novi Arvarita. I'm Ita Suherminingsih. Wallahul muwaffiq ala iqwamit thoriq. Wassalamualaikum warahmatullahi wabarakatuh. Maybe you take a picture? Please, for the dosen dulu ya. Monggo, maju ke depan. Monggo Bapak Ibu dosen, silakan maju ke depan. Pak Cepi, Pak Fawaid, Pak Rizwan, silakan mahasiswa untuk mengambil dokumentasi dengan Prof. Hurry up, maju. Silakan. Ayo segera, Rek. Maju mungkin yang cowok posisi di depan ya, jongkok ya, biar cukup ya. Sebagian ada yang jongkok di depan atau di belakang, Di depan atau di belakang? Nah, cukup ya. Pak Faruk tolong menghilang dulu. Oke, bebas dong. Oke, thank you very much, Professor.